Good evening, ma'am. My name is Reshma and I am from CSE section from the Computer Science branch and second year. So today I am going to present an PPT in the subject of discrete mathematics and graph theory. And the question I have gotten on the topic is generating function method. So subject code is 23MAT07. So we are entering into PPT. First one is outline. What is recurrence relation? Methods of solving recurrence relations. Generating function method using generating function solved y of n plus 2 minus 4 y of n plus 1 plus 3 y of n equals to 0 when y not equals to 2 y1 equals to 4. So these two are conditions applied to this above question. Last will be conclusion. So moving to next slide. What is recurrence relation? A recurrence relation is an equation that defines a sequence of values recursively, meaning that each term in the sequence is defined in terms of one or more previous terms. This method is often used in mathematics and computer science to describe sequences such as Fibonacci sequence or to analyze algorithms. So moving to methods of solving the recurrence relations. Here are three methods to solve recurrence relation. So first method will be substitution method, also known as iteration method. Second method is generating function method. Third one is characteristic roots method. So the question we have got is from generating function method, which is the second method. So moving to next generating function method. So the generating function method is a powerful technique used to analyze sequences and solve recurrence relations. A generating function transforms a sequence a of n into normal power series a of x equals to sigma n equals to 0 to infinity a of n x power n by substituting the recurrence relation into this series. It allows for the manipulation of the resulting equation into an algebraic form. Solving for the generating function provides a means to derive closed form expressions for the sequence or extract specific coefficients. This method is particularly useful in combinatorics and algorithm analysis. So moving to next slide. The question which I have got is using generating function solved y of n plus 2 minus 4 y n of plus 1 plus 3 y of n equals to 0 when two conditions are given, y not equals to 2 and y1 equals to 4. Next, here go the solution given y of n plus 2 minus 4 y of n plus 1 plus 3 y of n equals to 0. So this is the given question with conditions. Multiply x power n on both sides and by summing we get summation of x equals to 0 to infinity y of n plus 2 x power n minus 4 summation of x equals to 0 to infinity y of n plus 1 x power n plus 3 summation of x equals to 0 to infinity y of n x power n equals to summation of x equals to 0 to infinity x power n. Equating n values in the equation, we'll get one solution line here. 1 by x square summation of x equals to 0 to infinity y of n plus 2 x power n x power square minus x 4 by x summation of x equals to 0 to infinity y of n plus 1 x power n into x power n plus 3 summation x power x equals to 0 to infinity x power n. So I have mentioned one formula here to solve upcoming steps in this problem. Sigma x equals to 0 up to infinity y n x power n equals to y0 x power 0 plus y1 x power 1 y2 x power 2 and so on up to infinity. So 1 by x square y2 x power 2 y3 x power cube and so on infinity minus 4 by x y1 x power 1 y2 x power 2 and so on up to infinity plus 3 y naught x power naught plus y1 x power 1 plus and so on infinity equals to 0. We know that one formula I have mentioned, a of x equals to summation x equals to 0 to infinity yn x power n equals to y naught x power 0 plus y1 x power 1 plus y2 x power 2 plus and so on infinity up to infinity. So adding of missing terms in the each sequence we have got in this below step. 1 by x square a power x minus y0 x power 0 minus y1 x power 1 minus 4 by x a of x minus y0 x power 0 plus 3 of a of x by previous formula I have mentioned. So we know that x power 0 equals to 1, y0 equals to 0, y1 equals to 4 from the equation itself. 1 by x square a of x minus 2 into 1 minus 4 of x minus 4 by x a of x minus 2 into 1 plus 3 a of x. So next, by taking LCM of the equation, we'll get a of x by x square 2 minus 4x minus 4x a of x minus 2 plus 3x square a of x equals to 0 whole divided by x square. So we'll get a of x minus 2 minus 4x minus 4x ax plus 3x square a of x equals to 0. By taking a of x common, we'll get an equation. So a of x into 1 minus 4x plus 3x square minus 2 plus 4x equals to 0. A of x 3x square minus 4x plus 1 equals to 2 minus 4x. So it is in the form of a partial fraction. Then we'll divide it into partial fractions. 2 minus 4x by 3x square minus 4x plus 1 from equation 1. We'll divide it a by 1 minus 3x plus b by 1 minus x. It is equation 2. Then 1 minus x and 1 minus 3x are roots of 3x square minus 4x plus 1. So 2 by we are calculating partial fraction here. For that, by cancelling both sides, we'll get 2 minus 4x equals to a plus b minus a plus 3b into x. By comparing LHS and RHS, we have calculated here. We are calculated a value and b value, whereas a value equals to 1, b value equals to 1. By substituting a and b in the equation 1, we'll get 1 minus 1 by x equals to summation of x equals to 0 up to infinity x power n. We know that this formula, by substituting, we'll get yn equals to 3 power n plus 1 is the total solution. So conclusion will be, in conclusion, the generating function method is an effective tool for solving recurrence relations and analyzing sequences. By converting sequences into power series, it simplifies the manipulation of relationships between terms. This approach not only facilitates finding closed form expressions but also aids in diverging coefficients for specific terms. Its versatile ability makes it invaluable in fields such as combinatorics, computer science, and mathematical analysis, providing deep insights into sequence behavior. So this is the end of my PPT presentation, and thank you very much.